Hello, you're welcome to this lesson. In this video, we are going to start with statistics and probability. Okay, so what I'll do is that I will take you through some few definitions which will help us understand the concept as time goes on. Okay, so let's look at the definitions we have here. The first definition we are going to look at is a random experiment. Okay, so if we say a random experiment, it is an experiment that even though it is conducted in the same way each time, it might have different results. Okay, so that's what a random experiment is. So you might perform the same experiment the same way, okay, but each time you are going to perform it, you're going to get different results. Okay, and then this is as a result of some randomness, okay, in the system that you are using to perform the experiment that you can't control. Okay, so because of those randomness that you can't control, you will end up getting random values at the end of your experiment. Okay, so we term this type of experiment as a random experiment. Okay, the second term is a sample space. So a sample space is the collection of all potential results from a random experiment. The symbol S stands for the sample space. Okay, so after let's say as you are performing your random experiment, okay, you are expecting to get some possible outcomes. Okay, and then what a sample space is that set of possible outcomes that you can get from your random experiment. Okay, so let's say we are tossing a die. Okay, when we are tossing a die, we can get the following outcomes. We can get a 1, we can get a 2, we can get a 3, 4, 5, or 6. Okay, so as you are throwing the die, you are expecting any of these values. Okay, so there's no way you're going to throw a die, then you're going to get 7, 8, 9 because the values are up to 6. Okay, so as you are throwing the die, you're expecting to get any of the values from 1 to 6. So this becomes your sample space. There's no way you're going to get a value outside this sample space. So that's what a sample space is. Okay, so there are two types of sample spaces. Okay, we have the discrete sample space and then the continuous sample space. Okay, so a sample space, okay, if a sample space has a countable infinite or finite set of possible outcomes, it is said to be discrete. Okay, and then if a sample space has row number interval, which is either finite or infinite, then it is considered what continuous sample space. All right, so let's look at what these two means. Okay, so for the sample space, we have two types, which is the discrete sample space and then the continuous sample space. Okay, so the difference between these two is that for the discrete sample space, okay, the outcomes are usually countable and then very, very distinct. Okay, the outcomes are countable and then very, very distinct. But for continuous sample space, the outcomes, okay, are not really distinct, and then there can be a lot of values between two outcomes. Okay, so that's what continuous in the discrete sample space is. So let's take an example. Let's say we are performing an experiment and then we are expecting a yes or no result at the end of the experiment. Okay, so it's either you get a yes or you get a no. Okay, so this will be your sample space. This type of sample space is a discrete sample space because one, the outcomes are countable and then they are very, very distinct. But let's look at an outcome like this. Let's say I'm performing an experiment and then I have an outcome, let's say value between 1 and 2. Okay, let's say you have outcome between 1 and 2, and then this 1 and 2, I can have values like 1.01, I can have 1.001, I can have 1 point, I can have a lot of values, okay, between 1 and 2. It can even be infinite or can be finite, so we can have a wide range of values between these two intervals. So this type of sample space is known as the continuous sample space. Okay, so now let's look at this example here, okay, which will help us understand the types of sample spaces that we have. So the question says that take into consideration an experiment where a cell phone camera is chosen and the recycle time of flash, which is the amount of time needed to prepare the camera for another flash is what recorded. Okay, so what you're going to do is that you're going to look at the possible sample space that we can get for this question. Okay, so one thing you have to know is that for sample spaces, okay, you choose a sample space based on the analysis that you want to do at the end of what the experiment, okay, or based on the calculations you are doing, you choose a reasonable sample space. So for this question, for instance, you can get different sample spaces based on the different analysis that you want to do. Okay, so now let's look at the possible sample spaces that you can get for this question. Okay, so the first sample space you're going to have will be a set of positive real numbers. Okay, so this is because in this case we are considering time here. Okay, and then you know that time cannot be negative. Okay, time cannot be negative, and then what will happen is that we are taking a picture. Okay, and then after taking a picture, you record the time that it will take for you to take another picture. Okay, so in this case, what will happen is that we can't say time will be zero. This is because so far as you are taking a picture and then you are starting a camera, by the time you finish taking that first picture and then take the next one, the time a time would have been recorded. Okay, so you can't say that the camera will be fast to the extent that you will record a zero time between two flash sessions. Okay, so in this case, our possible answers are just going to be positive real values, right? And then you know that time can be measured into very very small units. Okay, so in this case, you can have a set of what positive real numbers as our sample space. So you can get a wide range of time values measured. Okay, within this range. So this is one sample space that you can get for this question, which is a set of what positive real numbers. Okay, so you can record a lot of time values, okay, for this experiment if this is our sample space. Okay, and then one thing is that we will consider this sample space to be a continuous sample space. Okay, we consider this to be a continuous sample space. Okay, so this is because we are just considering a set of positive real numbers in general. Okay, and in this set of positive real numbers, you can have decimal values there, right? You can have lots of decimal values there. Even if you are considering just one and two, we can have a lot of decimal values between one and two, which are very similar to each other. Okay, they are, it will be like a continuum. Okay, where the difference between the values are not really significant. So you see that you can get a high range of values between this one and two, and then considering we looking at a whole range of what positive real numbers, so you see that we can get a wide range of what possible outcomes from this sample space. So we will term this sample space as a continuous sample space. Okay, and then I said that we choose sample space based on the analysis that you want to do at the end of an experiment. So let's say if we are actually looking at recycle time between some interval. Okay, so you can see that you are looking at recycle time between 1.5 seconds and then 5 seconds. Then we can see that our sample space will be x, okay, such that x is greater than 1.5 seconds but less than 5 seconds. Okay, so in this case, the experiment that we are performing, our main goal is that we are expecting that the possible time that the possible time values that will be measured will be between this range. Okay, that they are going to be values that are they are going to be x values, okay, such that x will be greater than 1.5 or less than 5. So we are going to get we are expecting to get values within this range. Okay, and then one thing about this range too is that I'm going to say that this is also a continuous sample space. Okay, because we are measuring time, and then time can be measured to very very small units. Okay, so that means that it's possible that we are going to get decimal values there. So you are going to consider this also to be a continuous sample space. Okay, all right, so in the case, okay, you might be wondering why I'm considering this as a continuous sample space, and I'm saying that this is because we can get a wide range of decimal values between this range. Okay, but in a situation whereby you are not considering decimal values, then we can consider this as a discrete sample space because the values that you are going to get between 1.5 to 5. Okay, will be countable. Okay, and then they are going to be very, very distinct because we are not going to consider decimals in that case. So in such a case, you can consider it to be discrete. But in this case, that for time, you can get very, very small values, okay, even to decimal places, then we are going to consider it to be a continuous sample space. So now let's look at the third sample space that you can choose for this question. Okay, so let's say the main objective of our analysis at the end of the experiment is to determine whether the flash time of the phone camera is low, medium, or high. Then in that case, our sample space is just going to be low, medium, okay, or high. Okay, so at the end of the experiment, we are expecting a camera, okay, flash time, okay, to be either low, medium, or high. So these are the possible outcomes that we can get at the end of the experiment, depending on that particular analysis that you want to do. So you will term this also as a discrete sample space because one, the outcomes are distinct, and then they are countable. Okay, they are countable. And then the last sample space that you can also get will be a yes or no sample space. Okay, so in this case, we can choose a certain criteria for the flash times. Okay, so maybe you can see that if a camera takes 1 second, okay, if a camera takes 1 second for the next flash, then we can give it a yes. If a camera takes more than 5 seconds, then you can give it what, a no. So in this case, we are just looking at cameras that are either yes or no. Okay, so in this case, our sample space will be yes or no because those are the possible outcomes that we are expected at the end of the experiment for our analysis. And then we can term this also as a discrete sample space. Okay, so that's all for the introductory part. Thank you very much for watching this video. If you find this video useful, please make sure you like the video and subscribe to the channel.